Welcome to another episode of Fort Bend Mathematics Tutoring. Take a moment to soothe your nerves. Remember, these is just numbers. They can't hurt nobody.
Hello, ladies and gentlemen. This is Mr. Witt with Fort Bend Tutoring, and today's tutorial is going to be about function operations. So let's check it out. All right, ladies and gentlemen, we have the function operations here, the first of which is f plus g of x. What does that mean? That means that you have two functions, one named f, the other named g, and you're going to simply add them together. So f plus g of x simply means f of x plus g of x. That's it. You just add the two functions together. Then, when you're looking at f minus g of x, you're going to subtract the two functions that they're referring to. So you'll take your first function named f minus the second function named g, and then you simplify it, and that's it. So then you move on to the next one, which is going to be fg of x, which means that you're going to multiply these two functions. So that simply means that f of x times g of x, and then of course you simplify your results from there. Finally, you're going to end up with f divided by g of x, or f over g of x, and that's simply going to mean that you're going to find the quotient of the two functions. That's right, make it into a fraction, simplify it, and done. All right, so let's look at some examples. All right, in our problem number 1, we have the two functions that are given. One is named f, and it's defined as x squared plus 3. So f of x equals to x squared plus 3. Then you have your g function. G of x equals to negative 2x plus 6. So what do they want us to do in A? They want us to add these two functions together. That's right. We know that f plus g of x simply means to add the f function to the g function. All right, solving our problem here, we'll be adding the x squared plus 3 plus, we'll have the quantity of negative 2x plus 6. I'm using parentheses because this first term in our g function happens to be negative. So I wanted to make sure that I don't forget that that's a negative sign just on the 2x. From here, I'll be simplifying this by rewriting it as x squared plus 3, and then since this is technically positive 1 times the quantity, I'll end up bringing down this negative 2x plus 6. That being the case, we can now combine any like terms and write our answer in descending order of the variable. So I'm going to end up with a result that is x squared minus 2x, and then combining positive 3 and positive 6, I end up with a positive 9 for my answer, and I'm going to put a red box around that so you'll know that that's it. And done. That's it, ladies and gentlemen. That's 1A. That was 1A. All right, let's continue on. In part B, they want us to find f plus g of 3. Now, remember in our previous step, we already found out what x squared minus 2x plus 9 is, right? So technically, all we have to do is replace every x in our response from our previous answer with the number 3. And that's exactly what I'm going to do. I'm going to end up with 3 squared minus 2 times 3 plus 9. All right, so that will give me the following result. I'll have 9 minus 6 plus 9, and then from there, 9 minus 6 gives me 3, and then finally 3 plus 9 is 12, which is the answer. All right, you did have another alternative in solving our part B, and that is, let's say that you didn't already have this x squared minus 2x plus 9 portion already solved. What you could do is you can find out what f of 3 plus g of 3 will give you. All right, and so let's check out this method real quick. So let's replace every x in our f function with the number 3. So going back to the original, replacing x with 3, you would have 3 squared, which is 9, and then 9 plus 3 gives us 12, right? Okay, so we end up with 12 right here for our f of 3 value. Then let's check out g of 3. So plugging in 3 into our second function for g, we'll have negative 2 times 3, which is negative 6, and then negative 6 plus 6, well, those are additive inverses. That's the opposites of one another. So that means they'll equal to 0, because negative 6 plus 6 is 0. So that being the case, we can come down here and say that, hey, we're going to add our g of 3 value, which is 0. So 12 plus 0 gives us 12. So once again, we end up with positive 12 for that result. So if you already know what your f plus g of x is, you would replace those x's with the value of 3, and that'll give you your response. But if you don't already have your f plus g of x solved for, you can just go back to your original functions, plug in 3 into both of those, and then do the operation, which in this case was addition. So we found out that f of 3 was 12 and that g of 3 was 0, and 12 plus 0 gave us the same response, which is 12. All right, so there you have it. 2 methods to solve the answer. That's right. FBT gives you choices. We're going to move on to the next problem. All right, let's keep it moving here. In problem number 1, still number 1, right? Yeah, but we have C and D, okay? So that means we'll just continue with the next part. So you're using the same F, you're using the same G functions, and you're going to be doing a different operation this time. That's right, this is about function operations. So this part is about subtracting the 2 functions. And so they want us to find F minus G of X. So that's what we'll do. We'll go ahead and subtract these 2 functions together. So I'm going to write my setup as x squared plus 3 minus the quantity of negative 2x plus 6. All right. It's very important to put that second function in parentheses because that negative, that minus sign there is going to distribute to every single term inside the parentheses. In other words, I'm about to get my arrows popping, okay? Just like that, about to get my arrows popping, because if you've been keeping up with me, I love the distributive property problems. Yeah, I love to get my arrows popping. Just make note of that. It's going to be on the test. So continuing on, after I distribute, I'll have x squared plus 3. A negative times negative 2x is a positive 2x. A negative times a positive 6 is a negative 6. And then from there, I'm going to combine any like terms I may have, as well as write my result in descending order of the variable. So that means I'll end up with x squared plus 2x minus 3, and done. That's it. That's it. Oh, you're complaining about that too? Boy, you guys are picky. Okay, that's a better 2. That's a better 2. I'm going to put a red box around here. All right. Thank you. And there you have it. Now, in part D, they want you to find f minus g of negative 1. All right. So remember, since I already know what f minus g of x is, I can plug in negative 1 into that previous response, and that's what I'll show you right now. We'll end up with negative 1 squared plus 2 times negative 1 minus 3. All right, we know that negative 1 squared is positive 1. 2 times negative 1 is going to give you negative 2, and then I'll bring down that negative 3 next. From here, 1 minus 2 gives me negative 1, and then I'll bring down that negative 3, and finally, negative 1 minus 3 is negative 4, which is the answer. All right, there you have it. We can take the difference of f of negative 1 and g of negative 1 and find our result. So going back to our original functions, let's plug in negative 1 into f. So negative 1 squared, meaning negative 1 times negative 1, is a positive 1, right? And then 1 plus 3 is always 4. All right, so let's write that down. 4, like so. Then I'll say minus the result from g of negative 1. So plugging in negative 1 into our g function, we'll have negative 2 times negative 1, which is a positive 2, and then 2 plus 6 is always 8, right? So let's go ahead and say that we have 8 here for our g of negative 1. So then simplifying this, 4 minus 8 is going to be negative 4, which is my answer, and done. Negative 4 is the result. So you can go ahead and choose which process works best for you. Either utilizing the fact that we already had f minus g of x and then plugging in negative 1, or simply expanding the process into finding the difference of f of negative 1 minus g of negative 1. Still the same result. So it's up to you, whichever one you prefer. Matter of fact, send me a comment, let me know which one you like, okay? How about that? Let's continue on, ladies and gentlemen. Let's move along. Moving along now. All right, we're still dealing with the same f and g functions, right? But now in part E, they're asking us to multiply these together. So I'm going to set it up like so. I'm going to have my binomial, that first one, which is going to be x squared plus 3 times the binomial negative 2x plus 6. Now, what you can do, ladies and gentlemen, is you can check out our video over multiplying binomials, in which I show you 2 different ways to multiply those together. So if you're feeling a little rusty on the FOIL method and distributive property, where we get our arrows popping, by the way, you can go ahead and check that out and see which of those methods you prefer. Okay, so I prefer to get my arrows popping, so that's exactly what I'm about to do. So I have my arrows popping over here, and I'm gonna go ahead and multiply this out. All right, so starting out, I have x squared times negative 2x. That gives me negative 2x cubed. I also have x squared times 6. Well, that's going to be a positive 6x squared. Then I'll be multiplying 3 times negative 2x. That's going to give me negative 6x. And then finally, 3 times 6 is 18, like so. All right, so now we just get to see about combining the like terms and writing our answer in the descending order of x, right? Well, looking at each of these 4 terms, none of these are like terms. None of these are like terms. They're all unlike terms, which means I cannot combine any of these terms together. That means that this is the answer. Yeah, that's it. Putting the box around it. I'm done. That was part E. So fg of x simply means to multiply those 2 binomials together from your original functions, and that's the result. That's the answer for that problem. That was part 1E. Now, in 1F, we're asked to find f divided by g of negative 1, or f over g of negative 1, or the quotient of f and g negative 1. All right, so different ways to say it, same result. This means that I have f of negative 1 divided by g of negative 1. All right, and so continuing this setup, I can show that f of negative 1 would be negative 1 squared plus 3 divided by negative 2 times negative 1 plus 6. So this is my setup thus far, showing that I've plugged in negative 1 into the f function in the numerator, and then I plugged in negative 1 into the g function in the denominator. Okay? From there, we have the following. We can go ahead and show that we have a positive 1 plus 3 in the numerator here, and I'll just go ahead and show this step. And then negative 2 times negative 1 is positive 2 in the denominator. And then simplifying this further, we have 1 plus 3, which is 4, over 2 plus 6, which is 8, and this simplifies to 1/2, and that's the answer, ladies and gentlemen. Done and done. So that was 1F. All right, let's continue. We have more to show you. Finally, we're on to problem number 2. How about that? In problem number 2, I have f of x equals to x squared plus 1, g of x equals to 3x plus 5. So here in problem 2b, they're looking to find f minus g of negative 3. So being as though I'm not already given my f minus g of x, I'm going to go ahead and do the following. I'm going to go ahead and find out what f of negative 3 is, and then I'm going to subtract from that g of negative 3. Yep, just like so. So let's go ahead and see what happens when we plug in negative 3 into our f function. So negative 3 squared, meaning negative 3 times negative 3, is positive 9. Then 9 plus 1 gives me 10. So I have a result of 10 here. Yep, just like that. Then this will be minus my g of negative 3. So plugging in negative 3 into the g function, let's see what happens. It will be 3 times negative 3, which is negative 9, and then negative 9 plus 5 gives me a negative 4. So this is going to be negative 4 here, and notice I had to add those parentheses to ensure that you know that the value is negative 4 and not a part of the minus sign there, okay? So from here, simplifying this, the opposite of negative 4 is positive 4. In other words, a negative times a negative is a positive. And then from here, we have 10 plus 4, which gives us 14, and this is the answer. Oh yeah, all right, red boxing it. Done. Okay, I like that. That was not a bad process. Okay, let's move on to the next one. Continuing on with the f and g from problem number 2, we're going to find out our next result, which is 2c, and they want us to multiply the functions together. All right, so anytime you have your 2 variables, those 2 names right next to one another, you want to multiply them together. All right, so once again, I have a binomial times a binomial. So here we're given x squared plus 1 times the quantity of 3x plus 5. All right, so once again, I'm about to get my arrows popping. So here we go. Favorite property, distributive property kicks butt. We have it, x squared times 3x. That's going to be 3x to the 3rd power. Then we have x squared times 5. Well, that's just 5x squared. I cannot contain my excitement. 1 times 3x is going to be 3x. And then 1 times 5 is 5. I can do this all day long. Oh, I do. Yeah, actually I do. All right, so this is the answer. I know it's the answer because none of these terms are like terms. That's right, their variables all have a different exponent on them. So we can't add or subtract any of these terms, which means this is the answer. I'm putting a red box around it. Red boxing it, just like that. That's it, ladies and gentlemen. That's that problem. I am so moving on to the next problem now. Now, check it out. I have fg of 5. Well, that means I want to multiply the functions together and see what the result is when I substitute their x's with 5s, right? So I can take the response, I can take the result from the previous answer here and simply plug in 5, or I can plug in 5 into the original functions and then multiply those results together. Let's do both. I'm tempted. So here, we'll have 3 times 5 cubed plus 5 times 5 squared plus 3 times 5 plus 5. All right? So that's what I have thus far. Okay. So knowing that the exponents will come in next in our order of operations, this is going to be 5 cubed, which is 5 times 5 times 5, which is 125, and 3 times 125 gives me 375. All right. Then this will be plus 5 times 5 squared. Well, 5 squared is 25, and then 25 times 5 is 125. I'm feeling good. Then 3 times 5 is 15. Got it. I'm going to bring down that last 5. Okay, so this is how it looks so far. From here, we'll be combining 375 plus 125 to get a result of 500. Then 500 plus 15 is 515. And then 515 plus 5 is 520. So in other words, add all these numbers together. You'll end up with 520. And that's the answer. That's it. Red boxing it. Yeah. Oh, you wanted to see that other technique. All right, let me show you. What you'll do is you'll find out what f of 5 is and multiply that times g of 5. So this is the alternate way to solve the problem. So let's go back up to our original functions here. All right. 5 squared, ladies and gentlemen, is 25. And then 25 plus 1 is 26. All right, 26. That's the value of f of 5. Then I'm going to multiply times that the value of g of 5. So going back up here where g is and replacing our x with 5, 3 times 5 is 15, and then 15 plus 5 is 20, right? Okay, so let's come down here. This is going to be 26 times 20. And ladies and gentlemen, all you had to do is know that 26 times 2 is 52. And then 52, and just throw a 0 behind it, will give you 520. Same answer. Yep, boxing it. And done. Same result. So whichever one you like the best, whichever way you like the best, that'll give you a result. Okay, let's keep moving. Keeping it moving, ladies and gentlemen. We also have our problem number 2 functions, and we're asked to do the following. To find out f divided by g of 0. So this means that we'll be plugging in 0 into our f function and dividing that with the result of plugging in 0 into our g function. And if we wanted to continue this setup, I can show that I have 0 squared plus 1 divided by 3 times 0 plus 5. Yep. Okay, great. Now in the numerator, 0 squared is just 0, and then 0 plus 1 gives me 1. In the denominator, 3 times 0 is 0, and then 0 plus 5 is 5. So that's my answer. Got a box around it. Continuing on. All right. Here, in part F, they want us to find out what f divided by g is of -1, so we replace a -1 into our f and g function and divide, right? I'm going to show that this means f of -1 divided by g of -1. So substituting these values into the original functions, I'll have -1 squared plus 1 divided by 3 times -1 plus 5, just like that. All right, so recall our f function is x squared plus 1, our g function is 3x plus 5, and I replace the x in each of those with -1 to get the following. All right, now let's simplify. So -1 squared means -1 times -1, which is 1, plus 1 in the numerator, over 3 times -1, which is -3 plus 5. All right, these stray marks are killing me. So we'll end up with 2 over 2. Okay, so our answer is 1, just like that. Okay, good problem. That's it. Any questions? All right, let's move on then. Let's move on. You don't have any questions. You're good. You're happy about this. All right, in problem number 2, we're still using the same f and g function. However, in part G, they want us to find f divided by g of x and its domain. So first of all, this means that we need to find out what f of x is divided by g of x. And we've been given those values of f of x and g of x, right? My f function is x squared plus 1 in this problem, and my g function is 3x plus 5. All right, I cannot factor or simplify that any further, which means that this is my f divided by g of x. That's the result. The next part of the answer is that we need to give them the domain. And in the denominator here, that's my only concern, because as far as the domain is concerned, you're trying to avoid domain restrictions. And in this problem, I have a domain restriction that says that I can't have a 0 at the denominator of a fraction. You cannot have 0 as a value in the denominator of a fraction. It's undefined. So therefore, let's set that denominator not equal to 0. This 3x plus 5 value cannot equal to 0 because that'll make the whole function undefined. So we'll go ahead and solve for it. I'll subtract 5 to both sides, like so. I'll end up with 3x, it cannot equal to negative 5, and then dividing both sides by 3, I find out that x cannot equal to negative 5/3. Yeah. All right. So, for some teachers, that's going to be fine. That'll be the answer. That your domain could be defined as x cannot equal to negative 5/3. Other teachers, however, they'll want you to have interval notation. So to express that further, if I had a number line here, and I showed that I had negative 5/3 on here, and I can't have a value of negative 5/3, but everything to the left of negative 5/3 is good, and everything to the right of negative 5/3 is good, I can show my interval notation as negative infinity to negative 5/3 union negative 5/3 to positive infinity. All right. Okay. So it looks like that in interval notation. Just like that. So depending on which way your instructor or professor or teacher or your mama or dad, however they want you to submit your answer, you can use either way and be good. All right. That completes this lesson on function operations. We've gone over addition, subtraction, multiplication, division, as well as finding the domain when you're dividing, all right? So once again, ladies and gentlemen, please rate, comment, and subscribe. If you're able, please donate. That helps us bring you more free math videos from me, Mr. Witt, and FBT. That's Fort Bend Tutoring. Peace.
We certainly hope you enjoyed today's mathematics presentations. Did you learn anything? Do you need to review your notes? Take a deep breath and congratulate yourself. I am learning mathematicals.